it's not a, in terms of memory, it is not a consecutive memory, but it is a block of memory is connected to the next block of memory and the next block of memory through a link address. So if you take an example here, if you see 1, 5, 9, 12, there is the link address which is pointing from 1 to 5, 5 to 9, and so on. So you can see the difference also here. There is a link address in the linked list, whereas it's an array, you have a consecutive memory location. So I think this is fairly clear, but then here is what a linked list is. A linked list is you start from the head and you traverse from the head to the tail and using the next pointer. So that is what, so in case of array, what you do is if you want an element, a third element, you do a of 3. Let me take. So if you want to get to a of 3 is equal to 12, or in case of if you want in a linked list, what you do is you go from the head, and from the head you keep going to the next pointer and next pointer and next pointer. So a typical linked list element here, I think I've used Java class or a C++, I don't remember. Node, you have a node, data is just an element to tell us what we want to point to, what the node element contains. It can be an integer or anything we have. For right now, we'll go with all our operations with integer structure. And the node has an itself pointer, and that's pointing to the next, and so on. So this is an abstract public class, constructor class, so we can ignore that for now. So what do you do? What are the typical operations we do? We do an append. Append means adding to the end of the linked list. Prepend is to adding it to the tail of a head. Sorry, append is adding to the tail of the list, and prepend is adding to the head of the list. So here is what the code is. So let's go quickly to the append. So append, when you add to the tail of the, when you want to add to the tail, and this is where you go here. This while loop you see here. While loop is as long as the current next is not null, you keep going to the end. And once you hit the end, you come out at the current dot next is null, you come out, you add your new node. The first few lines is what if this is the first element in the queue, right? Element in the linked list. And that's when you add the first 3 lines. Head is equal to null. Yes. So can you see me highlighting that code using the highlighter? That
Yes, yes.
okay. So the next after append is prepend. Prepend is always to the always adds an element to the beginning of the list. So you just have to modify your head. So you take your save your head, get a new object. The new head's next is equal to head, and the head is pointing to the new head. So this is also straightforward. And I might be going a little bit fast because I'm assuming this is just because it's a brush up review session. I'm not going to go into details. Feel free to stop me if you need any further questions to be answered. So deleting a particular value. Say suppose you want to delete. So that when you have to delete, there are multiple nodes, entities which you want to delete, right? You may want to delete the head of the list, or you want to delete the middle element, or you want to delete the tail of the element, right? So let's say if you're going to hit, the head case is the most easiest case. So if head of the data is equal to data, so all you do is you take your head point, this is your current head, take your heads next, and then take the head dot next, point it to the head, and that's your you have deleted the first element here. So basically you're taking out this link out. So that is first element. What if you have to go and delete to the middle or the last element, right? So this is what you're doing. So at any point you go, you have a pointer called current, and you keep going as long as the current dot next is not null. And then if current dot next dot, you need to identify where your node is, right? And how do you identify? As long as you know your current dot, while your current dot next is not equal to null, and this current dot next dot data is equal to, see, current dot next is this, and if this data matches with the value you wanted, then you go specify current dot next is what is here. This is what you want to delete. So your current dot next will now automatically point to currents dot next dot next. So this pointer is essentially I'm doing is I'm pointing to this element. So essentially this two elements, the links gets dropped out the minute I identify this value. So as once I've done with that, that's all I need. That's called for deleting the data. So in case whether you're pointing to the end of the node, so if you're pointing to that, this is all, this element will point to the null in that case. If this is the last element, if you want to delete. So I'm moving on to the next. So is this clear for delete? So in general linked list, all we need to just be able to visualize where the links are going from link 1 to link 2 to link 3, where is at any point of time